we have here, what is the Lewis structure of HCO2? So this would be hydrogen carbonate ion. And the reason why I say that is because HCO2 minus, okay? So we're going to assume that it's referring to HCO2 minus and not HCO2 minus. That would be a little bit more complicated. So what I like to do, the reason why I say hydrogen carbonate is because what usually helps me is I like to separate the hydrogen typically from the molecule, because what we're really dealing with is just a carbonate ion and a hydrogen ion, or just a proton. Okay, so how do I know this is carbonate? Just as a quick review. Okay, so carbonate, that would be known as CO3 2 minus. This is carbonate. Okay, CO2 2 minus is carbonate. Okay, this is how I can name it as hydrogen carbonate ion. Just as a quick nomenclature review, just really get familiar with your ions. Okay, so now with that being said, we're actually going to now first just solve the Lewis structure of this one here. So it has 2 minus. So we have here, okay, carbon is on the 14th column, so that's 4 electrons it can donate. And oxygen, that's 6 valence electrons times 2, so that's 4 plus 12. And then we have the charge of minus 2, okay, which is how we have 2 more electrons. Alright, so in total we need 18 electrons in this carbonate ion. So we have now CO, okay, so that's what we're going to start with here. And now we're going to fill out the rest of the octet rule. Oxygen 3 4 5, because it's now sharing one of its 6. Same with this one, 1 2 3 4 and then 5 there. And carbon right now is sharing 2 of its 4 electrons, so 1 2 3 4. That will be it for this one. But as we discussed, we actually have 2 extra electrons. So what I'm going to do here in this case is, just to make sure that we can do this perfectly, I'm going to add 1 electron here and 1 electron there. Okay. The reason why this has been done is because we need to set this up in a way to where the octet rules are filled, and also we've now, I guess, adjusted for every I guess situation here. So just to make sure, now we should have 18 electrons. Let's quickly count through the double bonds. I mean, the bonds have 4 electrons: 6 8 10 12 14 16 17 18. So perfect. All right, so now let's actually go ahead and now throw this one here. Oops, these two form a double bond. Okay, and so now we have carbon like that. It has a double bond here and a single bond there. Okay, and just to make sure, 1 2 3 4, perfect, following the octet rule. And now the oxygen as well is going to be like that. Okay, so with this being said, now let's actually make sure we have the right formal charges, because this will actually help us determine where we put the hydrogen. Okay, so we would have, as you can see here, carbon. Well, actually, let's start with the oxygen on the left, or it doesn't really matter. This will be the neutral formal charge for oxygen: 2 bonds and 2 lone pairs. Okay, so as you can see, only this oxygen really follows that. So this one, we can say that has a formal charge of 0, so we won't write anything. But this oxygen here has instead 3 lone pairs and 1 bond. When you replace a bond with a lone pair, you go into the more negative side. You've added an electron. So this one here is actually going to be -1 for the formal charge. Okay? And now, the carbon, all right, usually wants to have 4 bonds, 0 lone pairs. Once again, similar to the oxygen, it's gotten rid of a bond and added a lone pair. So that right there would actually be a formal charge of -1 as well. Okay? So the hydrogen is a plus. This hydrogen will be able to go into either the carbon or the oxygen to be able to now balance this out. But here's the issue though. If we actually now look at the electronegativity, or typically things that like to add electrons, just be able to make the most realistic thing. Carbon has an electronegativity of 2.55 and oxygen has an electronegativity of 3.44. The affinity for electrons is greater on the oxygen, which is why if an extra hydrogen was added in, it would actually go onto the carbon right here. And this right here, if we were to now redraw it, okay, we would now have oxygen with still the double bond with the carbon. Carbon now bonded to the hydrogen, and then this oxygen here, it still has a formal charge of -1, which makes sense because HCO2 minus just have a anion and it has a net charge of -1, which is where it's on the oxygen. And as you notice, the carbon no longer has a formal charge of -1 because now it satisfies its original net charge of 0, where it has 4 bonds and no lone pairs, as you can see now. So this right here would be the Lewis structure for HCO2 minus, so hydrogen carbonate ion. That's what they have here. They have, as you see, this top oxygen here has the 3 lone pairs and 1 bond, and then the oxygen to the side has 2 bonds and 2 lone pairs, and then the hydrogen has just 1 bond, 0 lone pairs, and the carbon now has 4 bonds and 0 lone pairs. And that's how we get the minus on the outside, because that's where it is, on the oxygen. So let's move on to question number 7.